Okay, so this video is going to talk about how to use the assembly environment in Onshape. So many of you have noticed that you have the assembly tab, assembly 1 always pops up when you create a new part studio, and we've never used that before. So we'll talk real quick about how to actually use some of the tools that are available in the assembly environment. We'll start off with the basics, and I'm kind of learning along with you here. So uh, we'll be kind of exploring all of these different options along the top. So the first thing you're going to want to do is you need to put your parts into this assembly. So you've created some parts in the Part Studios. These are those blocks we created at the very, very beginning. So I'll be having you play around with these tomorrow. And so up here at the top left, you've got the insert button. It's going to look very, very similar to when you've inserted things into a drawing document. So all you have to do is just scroll through, find the part that you want. You can move it around, or if you just hit the check mark, it'll automatically snap in at the origin. And you can insert multiple parts this way. So if I wanted to put in a part 4 and a part 2, I can just keep going, inserting as many parts as I need. And you'll see right now they all just kind of move around however you feel like. So the first thing you're going to want to do whenever you start an assembly like this is to lock the first part into place, just so that you have something to build off of. To do that, you're going to right click on the part, and then third of the way down is the option to fix that part. And you're going to see over here this little symbol. It says the part is fixed, and that just means that it will not move at all. It's not constrained in any way that's meaningful. It's just locked into that place. That is the only part you should ever be doing that with. The rest of these have to get assembled using the actual mates or joints. So we have up here at the top all of our different mates. These let us pick the individual mates that we want. This one is lets you kind of switch between them and kind of see which one you like the best. It'll try to pick one that's relevant, but it's probably not going to pick the right one all the time. At this point, it would be a great time to go ahead and talk about degrees of freedom. The Project Lead the Way page that I also linked to on the Canvas page, remember you have to log in to get to this one, has a really good video on degrees of freedom right here. It's pretty short, like a minute long. I would highly encourage you to watch that. There's also a 4-minute video on all of the different types of joints, or Onshape calls them mates. So the only real difference here is that, again, Onshape calls them mate instead of joint, and this rigid one Onshape calls fastened. The rest of them are all the same. There's a revolute, there's a slider, there's a cylindrical, there's a pin slot, there's a planer, there's a ball, and I think there's actually even a separate parallel, which is just a planer with a gap in the middle. So we'll take a look at all of those. So back here, degrees of freedom, again, watch that video, but it's basically just the different ways that you can move. And what that relates to is the 3 dimensions. So I can move this part up and down, that's 1. Side to side, that's 2. I can bring it forward and back in the 3rd dimension, that's 3. And then the other 3 come from being able to turn this part. So I can turn it this way, I can turn it this way, and I can turn it that way. So there's 3 different axes that you can turn this around. You can't actually turn them when you're dragging. You have to apply the constraints to get them to turn. So let's talk about that next. So when you look up here at the top, this mate connector, that one's going to be kind of your most basic one. But if you take a look at all of these other ones, these are the joints that we're going to be using. This is your fastened, so the same thing as rigid in Fusion if you watch that video. We've got a revolute, so think of things that can rotate. That's like a hinge, so that'd be the thing you'd use for that box we just created. A slider can still turn, but now it can go in and out. Think of like the hinge pin. That thing still has to be able to slide in and out. That would be a slider mate. Planer mates are when you have something that's going to sit flat on the plane, 2 planes are touching, and it'll still allow movement in either direction, like X and Y directions. We've got a cylindrical mate. This is very, very similar to a slider mate and a revolute mate combined. So a cylindrical mate will let you turn and slide in and out. I think I said that wrong. Slider is only one direction, only in and out. Cylindrical lets you turn it and bring it in and out. And I'll show you that with one of the examples I'm going to do. Pin slot mate, I don't have one of those made. It's a little bit more advanced than I'm going to do right now. But again, take a look at the Project Lead the Way video, and it shows you a very good example of where a pin slot mate is and how it's different from a cylindrical mate. Then you've got a ball mate, which is a ball and socket joint. I'll show you one of those. And then you've got a planar mate. Those are your basic, parallel mate. It's very similar to a planar mate, only there's going to be a gap between them. So those are your basic ones. There's a whole lot of other stuff over here too for making like specific motions. If you have gears, anything like that is here. Tangent mate, again, it's separated by a little bar. It's a little bit more advanced. That would be like a ball rolling down a hill kind of deal. But we could play around with those later. We're going to talk mostly about these. What are there? 7, 8 of them right here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So let's start off with the fastened mate. That is the most basic one. This one will remove all the degrees of freedom. Okay, when you use a fastened mate, it is going to lock it together like there's a glue there. So what you do is when you click on this fasten mate and you start looking at the different parts, all of the different mate points are going to show up. So I can mate on corners, midpoints, centers. I can pick different faces and then pick the corners based on those. This is the part where you have to play around with this. Until you've spent some time doing it, it really is confusing. But once you play around with it, the whole point of the way these are designed is they're supposed to be kind of something that's intuitive once you get to learn them. So you have to spend time with these or you're just going to keep asking me how to do them. Play with it. The worst thing that happens is you hit undo, okay? So what you're going to do is you're going to pick the two mate connectors, the two places that you want. Now, one thing you want to be aware of, there is a difference between like highlighting this face and then picking this corner and highlighting this face and then picking this corner, or highlighting this face and picking this corner. That's going to decide which faces actually end up touching. So if I want to put this block on top of this block with this face on this face, what I'm going to do is I'm going to kind of zoom in, highlight this face, pick the corner I want. Then I'm going to go to this block, highlight the face, pick the corner I want, and you'll see that's not what I wanted it to do. So what I can do here is I can rotate along a primary axis. So now you see the primary axis is actually the z-axis. That's what I'm rotating on. Or I can flip it, and then I can still rotate it. And you can kind of see like, okay, I'm going to get in there, play around with these. This is the part where there's some things you gotta play around with here. So that one didn't exactly do what I wanted it to. So I'm going to undo that. I'm going to try it again. Pick a different corner here. There we go. So again, play around with these. You're going to learn more. I'm still not very good at this, as you can kind of tell, but eventually you'll get it to where you want it. So now with this fastened mate, what you're going to see is I can't move it anymore. It's completely fastened to that part. There are no degrees of freedom left. This one's fixed, but this one's just no degrees of freedom. Then I can go and do kind of the same thing over on these parts. Oops, I don't want to insert a new one. If I wanted to put this piece on top of that piece, for example, I can click on a corner. One thing that I find helps is zoom in, because if you're zoomed out, it's really hard to click on the face you want. So zoom in on the face you want, look at it, find the part that you want to match up to, and then you can kind of click on it. And so maybe that's what I wanted it to look like. Now, obviously, in real life, that would not work, but if I'm gluing these together, there you go. So that's the fastened mate. It'll just lock everything down, all 6 degrees of freedom. It will not move up, down, left, right, forward, backwards. It will not turn at all. It's locked. Now, let's take a look at some other types of these. So what I've got here is I've got just a basic stand-in for a bolt and a hole. So the first option we have is this revolute mate. And this one is going to have, it's going to remove all but 1 degree of freedom. It's just going to let it rotate about 1 axis. So what you have to do is you're still going to notice as you put these parts on, it's going to find various parts. And you want to think about where are these pieces actually going to be touching. So if I click on the bottom of this bolt, and then I click on the top of this hole, you're going to see that's really not what I want. If that bolt was really in there, it'd be down in the hole. But take a look at this. When I hit that play button, you're going to see it still rotates. That's the only motion that it has left. So what I want to do instead then is I want to make sure I click on the right mate connector. And I want this one at the top of the bolt to match up with this one at the top of the hole. And now you can see the bolt's sitting right down in the hole where it should be. And if I hit play, you see it still can turn because it still has that 1 degree of freedom left over. And that's the revolute constraint. You can also offset it if you wanted to, and you can change which axis it rotates around. So that's your other options that you have. So if I wanted to offset it, say it's supposed to sit up 1/2 inch, I don't know, why not? I can do that. That one actually went above, so I can just put in a negative number, and now it'll go the other way. I can also change which axis it rotates around. So if you look here, you can see the axes. See, right now the z-axis is the axis of rotation, but I can also say, okay, I want to rotate this thing around the x-axis a certain number of degrees. Now this is going to make it look a little funky, right? We don't want that. So in this case, we want to leave that alone. But that would be how you'd offset something if you needed to. If one of the mate connectors wasn't quite right, you could still make it work. So I'm going to hit X. You'd obviously hit the check mark if you wanted it, because I want to show you another one now. Next one we'll talk about here is the slider. Now this again removes all but 1 degree of freedom. It can still translate along the one axis. So if I click on this, what it's going to look for is, again, one of those points at the center of basically a circle. I guess it doesn't have to be a circle. So I'll put it there again, and I'll select the same exact point. Oops, I didn't click the first one. And now when I hit play, you'll see it doesn't turn anymore. It goes up and down. Now, I'm glad I made that mistake, because if you notice something, I clicked on those in the wrong order. The first part you click on is always going to be the one that moves. So I did that wrong. If I wanted to make it so that the bolt moved in and out, I need to click on the bolt first, then on the hole. And now you'll see when I hit play, the bolt moves up and down, not the block. The other thing you can do to fix that is if you fix the block in place, then it won't do that anymore. Okay, there's a few more in here. Next one I would want to talk about, let's talk about planar mate. So this is going to take two planes and lock them together, but it still allow translation in 2 directions. So there's 2 degrees of freedom left here. So again, I'm going to select a planar face and another planar face. And I don't like that. I'm going to flip it around. And now when I hit move, you see it can go left or right and forward and backward. And it can still turn. So I guess technically there's 3 degrees of freedom left over, but those planar surfaces always stay touching each other. So that might be useful. Next up, we've got cylindrical mate. So this is like a combination of slider and revolute. It's going to allow turning and in and out. But I'm going to pick the exact same things here. Let's try this one. Let's pick that one and that one. Oops, I didn't click on it. There we go. Now you'll notice here when I hit play, it can go round and round. It goes up and down, and those are what's left. The actual mate connectors that you select are going to be the ones that it kind of defaults to, though. You can also select limits. This will tell you how far it can go in any particular direction. And this is also where you can see how many options are left. So this has 2 degrees of freedom. It's got the Z translation up and down. It's also got the Z rotation this way. Okay, that is going to be the last one. No, let's do parallel mate as well. So parallel mate is very, very similar to a planar mate. You'll see they're parallel there. I can also flip them around. But when I hit play, instead of just being able to go left, right, up, down, spin, it can now go up and down. The only thing it's limited is it can't turn in relation. It has to stay parallel. And if I hit the limits, you're going to see I have a lot more options for limits. I can set the X direction, the Y direction, the Z direction, and the Z rotation, but there's no X rotation, there's no Z rotation because they have to stay parallel. Okay, so that's the last one I can talk about here. We will get to the pin slot in a little bit. I don't actually have a slot. I should make a slot. But I wanted to talk about the last one, which is the ball joint or ball mate. Again, Onshape calls them mates. Fusion, if you watch the video for PLTW, calls them joints. So ball mate, I'm basically just going to click the center of a hemisphere or a spherical area. I just clicked those in the wrong direction. Oops. Click them, the one you want to move, click first. So I click on that sphere, I click on that sphere, and you'll see it just kind of pops into that ball and socket joint. Now when I hit play, you can see it still moves around. I've got some room to go there. So if I hit the check mark now, you can see I can still, I forgot one of my steps, didn't I? Always a good idea to fix these. So I fixed the gray one. Now you can see that the blue one still rotates. Now, one thing you'll notice is it'll rotate right through itself, and there is a way to stop it from doing that. We will talk about that later. But for now, this is what I kind of want you to look at here. So what we're going to do tomorrow, actually, is I'm going to have these parts, all of these parts, for you to kind of play around with and try the different mates. Again, this is for the fastened mate, if you just wanted to lock it together like it's glued. And I'll also go ahead and just give you these parts, I think, so that you can have access to try these out. The very last thing we're actually going to do with this is we're going to put together a selfie stick. So I'll give you all of the different pieces of the selfie stick, and this is going to get you a chance to try all of the different constraints to put together a selfie stick. So that's kind of what's coming up in the next couple of days. Thanks for watching the video, and I'll see you tomorrow.